Alright, hello YouTube. It's about that time again for me to do another build and review of another 3D printer. Today in the mail, my Kossel from Folger Tech came in. I was really pleased with their Prusa i3. So these Kossel kits came out right before Christmas time, and I've got mine here. This is going to be the unboxing, and we'll see how it goes. Yeah, this again came from Folger Technologies up in Milford, New Hampshire, and this go around came with 2-day priority shipping, which is nice. I suppose I should dive into it. So here's the unboxing. Does look like the postman banged this one around a little bit. I don't expect there to be any problems inside, but corners certainly have shown some wear. I will note on the top of this box it does say Kossel Kit Rev A Beta, so it's quite possible that this is a first iteration, but we will see. Again, if anybody is interested, the link is down here, folgertech.com. They have a pretty nice website with a whole bunch of different stuff, 3D printer related to kits as well as parts. Packaging looks good, and it's paper packaging instead of the packing peanuts from the last go around, so that's kind of nice. Alright, let's see, what do we got first here? We have a bag of printed parts. Excellent. Let's get into that in a second. We have a wiring set. One thing I do really like about the Folger Tech kits is they really do label everything pretty nice. Ramps with the Adreno Mega clone, plus a bunch of stepper drivers and USB cords and end stops, and a screwdriver again. That's always nice. Last go around they gave a on the i3 they gave us these little non-conductive screwdrivers. That was nice. Alright, here looks like mounting spacers, extruder mount. This looks like all of the laser cut acrylic parts. Servo and tie rod ends. Okay, so this is going to have the auto level feature, as well as the tie rod ends and whatnot for the hot end in the center of that Kossel. If you guys aren't familiar with the Kossel, it is a Delta style printer instead of a Cartesian printer. Cartesian being the like the i3, the Prusa i3, where individual motors travel on X, Y, and Z axis. With a Delta printer, each one is moving vertically, and the combination of 2 or 3 moving vertically will shift the print head around. If all 3 move vertically, it goes up. If 2 move or 1 moves, it'll move it in one direction. So it's pretty a pretty neat design. Looks really cool. These are going to be the stepper drivers. Let's see here. Yep. 3 2.6 kilogram motors for the X, Y, and Z axis, and then the stronger motor for the extruder. So that's cool. Alright, next layer down. Here we have an aluminum heated bed, which is great, and it looks like this one has a external thermistor. I know on the i3 it was built onto the heated bed, but this is kind of an all-inclusive thing. Looks like we got, appears to be 3mm thick. I could be wrong on that, but I think 3mm thick aluminum plate with that heating circuit board right underneath, and the thermistor, which will be separate, which will be taped on with likely capped on tape. Here we have hardware kit with all sorts of things: bearings, nuts, bolts, washers, zip ties, all sorts of good stuff in there. And then here we have the extruder kit, 0.4mm nozzle. Everything's running at 12 volts. That seems pretty common. Capped on tape, tape to the outside. GT2 belt and pulleys. I believe these appear to be 36 tooth. Power supply cable. In here, I already know it is going to be another power supply, so that's good. These here are really cool. These are linear rails for the vertical slides. This certainly is an upgrade compared to most of the kits that are on the market. You're going to get much higher precision and accuracy with a nice linear slide. Not unlike the linear rods and bearings of an i3 kit, but this doesn't allow any kind of twist. So again, very good feature. I'll put that over here. And then here we have the extruded aluminum frame. I guess this is a 20 by 20 extruded aluminum frame. And then the longer bits are right here. These should be, I believe, 700mm. At least some of them are. Okay. Oh, these are cool. Here we have carbon fiber rod. Very neat. And there's some threaded rod in there as well. That will have to be cut when we start making the tie rods. Got some extra wire. It says extra 2 meters of 22 gauge wire. Always good to have extras. That appears to be it. And again, I compliment Folger Tech. Let's see if I can show you this here. You can see up here, they do a nice little checklist on their packaging process, trying to make sure everything gets in there. So next I'm going to inventory this stuff and make sure it all matches up with what should be in the kit. I have the manual up on my computer, which is in front of me this way. So I'll start figuring something out here in a second, but let me make sure I have everything inventory-wise. I'll get back to you. Alright, so I'm on to what the manual calls step 3 now, and I know I might have jumped a few steps on you. What I did previously is I just inventoried everything and measured out or separated all the hardware, because all the hardware for the most part comes in one bag. So I'm on to step 3, which is building the top assembly. What you're going to need is you're going to need your 3 top pieces, which are very similar to the bottom, only these ones are thinner. You're going to need all your bearings, the 6 flanged bearings and the 3 not flanged. You're going to need 3 button head screws, or bolts, excuse me. Don't need those. You're going to need 12 of the extruded aluminum nuts, or the T-nuts as they're called, I guess, and 12 of the M3 by 8, which is the shortest of the bolts in your kit. So you need all of that, plus you're going to need 3 pieces of the shorter extruded aluminum, which I need to grab out of the box here. Yep. I will say the extruded aluminum still has its protective tape on it for the most part. There is a bunch of filings kind of in the grooves of it, but the cuts look really nice. Possibly a little sharp, so do be careful on that. So I'm going to peel off the protective coating on here just real quick, because I'm not interested in pouring any more aluminum filings in my lap. While I'm building this, just a side note, I do keep a box just to the side for trash and things. That may be wise for you as well. Yeah, very nice extruded aluminum. Alright, so there's that. So what they say in the manual is you're going to take one of these button head screws and come in from the back side here. Tighten it in just enough so that I can start slipping some bearings on. It is the button head screws use a different Allen nut or Allen head screwdriver compared to these button heads. These button heads use a 2mm or number 2, I guess, 2mm, whereas the M3 regular style bolts, they're going to use a 2.5. So I'm just threading this on, and I'm going to put the flat one on, and now another flanged one. And the way it works, you keep the flange to the outside of the whole lot of them. Pretty nice. I'll show you here in a second. I'm just going to snug that down. So I have flange on the outside, non-flange in the middle, and then another flange on this outside. And that's going to be our guide for the GT2 belt. So I'm going to do that 2 more times, and then I'm going to get to putting on these T-nuts. Alright, that's all done, and I just tighten them snug. They don't go into any nut or anything, so I don't want to strip them out. Now it looks like we're going to go switch our Allen to 2.5, and these guys just go like so. Keeping them all loose because they're going to go inside the extruded aluminum. Ooh, that's a tight one right there. Tricky. There we are. That is a tight fit for my big fingers. So hopefully you guys have a little easier time. Yeah. if you have a ball end Allen head, so that you can come at it at a bit of an angle, that would probably make things, at least in this particular area, a little bit easier. So I am fumbling. Pattern ones are much easier. Alright, one down. Alright, ta-da! Now, what we're going to do is on each one of these, I'm going to put the extruded aluminum on one side only. Attempt to tighten it down. Again, very tight quarters in there. Alright, next one. All the same side. Make sure you put them all on the same side. I'll explain why in a second. Certainly go back and tighten these up when an opportunity presents itself. Okay. Wake up, computer. Alright, so we're going to place these kind of in this fashion here, loosely. You can turn the T-nuts, and they will slide through the gaps on the sides of the extruded aluminum. Makes this a little easier. Turn this up. Okay. I would recommend putting the bearings in after the fact if you have that luxury, just due to the tightness of of that. Anyway, so there's our top built, and I do believe that these little round bits can be clipped off or bent off or whatever you choose to do with them when that time comes, if need be. All right, moving on to the next step. All right, I'm moving on to step 4, at least step 4 of what the manual calls it, and it's building the base, which goes very similar to the top. Instead of bearings, though, we're going to be installing some stepper motors. And on the topic of stepper motors, you can see in the kit you've got 2 different sizes, 3 of one, 1 of the other. You want the 3 smaller of them. This will be for the extruder when that time comes, so set this one aside, but don't get them confused. Let's see. First thing I think I want to do is, yes, I want to install the T-nuts. You need 24 T-nuts. You need 36 of the M3 by 8. Again, those are the smallest one. You'll need the 3 pulleys. And by the way, the grub screws, or the screws to set those, is a 2mm 2 Allen, number 2 Allen. You'll need the 6 remaining short extruded aluminum, and your 3 corners. I did cut the little ears, or wings, whatever you want to call them, off the bottom. And because I am OCD, I'm going to make sure that I keep them all in the same orientation so that the word Kossel reads the same in every direction. So, again, I think this is going to be a challenge for my fat fingers, but you're going to take one of these M8 screws through here and put a T-nut on. You're going to do that 24 times on all of the four holes on each side of each one of these corners. All right. Oops. Wrong one. Put the extruded aluminum arms on, and again I'm going to do these the same way. I'm going to put all of them on the same side of each one of these, so that when it comes time to bring it all together, it meshes pretty easy. Moving along. Now our motors are going to be positioned in here, and I am going to position these so that the plugs all orient in the same clockwise direction. First thing, since, yep. I'm going to do is I'm going to place the pulley in the slot for the motor, but I'm not going to tighten it down. What I'm going to do now is again, using those number 8 screws. And there's holes at the top of each one of these extruded aluminum holes. There's holes so that you can actually run your Allen wrench to get to where the motors need to screw in. Pretty ingenious design there. Place this about where it belongs. But you do have to fix your Allen head bolt to it after your Allen wrench is through the hole. If you quit dropping the screws like me, you have a little easier time. Alright, and there we have the base built. Excellent. So, soon enough we'll move on to the next step. Alright, welcome back. Moving on to the next step, which is creating the tie rods for this printer. Let's see, it's called step 5 in the manual here. And what we need to do is we need to cut 6 pieces of carbon fiber rod to 180 millimeters each. And the way it's recommended to at least get some uniform measurements quickly, other than having to measure each one, is to use one of the T-nuts in your vertical aluminum extrusion piece, one of them, doesn't really matter which, and set it to exactly 180 millimeters, which is 18 centimeters. So from the front of the T-nut to the edge of this extruded aluminum is exactly 180 millimeters. And then you can just set your carbon fiber rod in there and then go about cutting it. I'm going to use a razor to make a mark where I need to cut, and that way I can then transfer this over to for when I cut. Now when it comes to cutting, they say to use a hacksaw with a 24 tooth per inch blade, or they recommend a Dremel wheel. I will use a Dremel. I have that. If you were going to use a saw, I do recommend you use something like a miter box. It could be something like this that just has grooves cut so that your blade goes straight through it instead of coming off at some weird angle. And when it comes time to Dremel, I'm going to make sure that I hold it directly parallel with the rod while cutting. I'll also use my Dremel tool, or cut-off disc in a Dremel, to cut this threaded rod. This threaded rod is for these tie rod ends. It'll end up going inside here, getting screwed in. So I'll cut this also, try to clean up the ends a little bit with the Dremel. Gonna need, I guess, 12. Yeah, one for each side of the 6 carbon fiber rods. So 30 millimeters in this, 180 for this. Again, try to make your cuts as straight or square as you can. So I'm going to do that. I'm going to run out to my garage really fast so I don't have to make a bunch of dust in the house. and I will come back and we'll start threading these tie rod ends on. Yeah, so I'll see you in a few to wrap up this. Alright, so I am back from the garage and cutting the carbon fiber rods. You can see here these are cut to length. All of them the same, coming up to the 18 or 180 millimeters. And then here is what the threaded rod was turned into, a whole bunch of little bits of threaded stock here. And what was left over, if you're trying to maximize what's left over, you have approximately, let's see, 85 millimeters of threaded rod, approximately, if you got the same length rod I did. And then 3, I don't know, 12 centimeter or 120 millimeter chunks of carbon fiber. Now when I was cutting the carbon fiber rods, I measured in from both sides like you would if you set up that jig using one of the extruded aluminum pieces. So I kept a factory edge on each side and just cut these chunks out of the middle. Made things a little easier because I noticed with my Dremel, and I might not have been going fast enough with the speed, that the ends have a tendency to want to fray just a little bit. You can kind of see here, maybe not, yeah, a little bit of frayage. So you want to try to minimize that if you can. I also, since I had my Dremel, you could do this with sandpaper or a little fine file, I did clean up the burrs on the end of the metal threaded rod, thread stock. So that's that. And they're close to the same length, you know, at least enough for what we're doing here. So the next step is you take one of the 8 millimeter cap head screws, as they call it, or you got an Allen head screw. And we're going to thread these tie rod ends, because I guess they're not threaded already. So we're going to take it, start it by hand, I think. This might be a little harder than I think. A little bit. Let's try this. It is soft plastic. Yeah, it works pretty good. Just gotta get started, then it goes pretty easily. So we're basically using that screw to cut threads. So I'm going to do that to the other 11 of these. There are 15 of these tie rod ends in your kit. You only need 12. So we have 3 extras. Lucky us. Alright, so that's all of them. Set that aside. The next step is to put the threaded rod into the tie rod ends. And how I recommend doing this is grab a pair of locking pliers, kind of set so that they'll grab on to the threaded rod, and look at your threaded rod and figure out which side is worse. If you marred up the threads or something like that in the cutting process. Because remember, we're going to be gluing half of this into the carbon fiber rod, so the threads don't count in the part that we're gluing. So we just want good threads that are going to go into our tie rod ends. And the second thing of note is that they say in the manual here that there should be a minimum of 10 turns that this threaded rod goes into the tie rod end. So 1, 2, grab this, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Oops. So we're going to make a bunch of these and then glue them in with the provided super glue. So there we go, we've got our 12 tie rod ends built. Now we'll take our carbon fiber rod and we'll be gluing the threads in, again with the provided super glue. They say that from bolt hole to bolt hole they need to be 224 millimeters. Kind of specific, and they do that for a reason. Let's see, 224, huh? So if that's centered on 0, that's centered on 0, 220. Looks like there's 220, there's 225 there, 224, so it looks like I'm looks like I'm about 4 millimeters long. So I might need to cut down my carbon fiber rod a little further, or grind it down. But that is the goal, and then glue them in to place. Alright? Double check again, that's an important measurement, that 224. So we will make sure that they're there before we do any gluing. Alright, I will get back to you, or come back with the next step in a moment. Alright, I wanted to take a minute, briefly, pause my build for a second to explain a little bit more about these tie rods. We know that the tie rods, if we look at one of the pictures of this model of printer, that they use pairs of these tie rods in 3 different directions, 120 degrees off of one another, to control and move around the print head on the printer. It's just how this design works. It is important that all the lengths be the same. I think I stressed that earlier, but I'm going to stress it again, that it's important that they all be the same. In the manual provided, you want 224 millimeters from bolt hole to bolt hole. That's important. And here's the kicker that I didn't say earlier. You want to make sure that your tie rod ends are in line with one another. You don't want them 90 degrees off. Now, if you didn't get glue on the actual tie rod ends and you only were able to glue the threaded rod inside of the carbon fiber, you should have the ability to twist the tie rod ends a little bit, should it be a little off of in line with the other end. If not, if you did get glue on everything, make sure that they are in line with one another. I can't stress that enough, because this won't work if one of them is 90 degrees off of the other on the end. You need to keep them parallel. So do please keep that in mind when you're gluing. The easiest way to do that as you're gluing is make sure that the little balls within the tie rod are kind of centered and pointing vertically. And then while they're setting up to dry, that they all rest on a table flat, so that you can see that everything is pointing the same direction. So again, stressing that, take a moment, make sure you do that right. 224 millimeters from bolt hole to bolt hole. Adjust the carbon fiber length as necessary. Again, I had to cut mine down a little bit. But yeah, make sure you do that so you don't have any problems later on. Alright, I'm back from making a slight modification to the tie rods. I had to cut an extra 5 millimeters off of them so that I did get that 224 millimeters from bolt hole to bolt hole. I'm assuming they want to go from center of bolt hole to center of bolt hole. So I had to cut off a little more. My rods were 175 millimeters instead of 180 as specified in the manual. What I would say is a likely cause of that is that when the manual was created, they used a slightly different tie rod end that might have had a different length to it. So the best thing I can say, since you don't know, you might have a different length tie rod than I got, is cut one at the 180 millimeters like they say, thread your two threaded rod chunks, sections into each side, and measure it. And if you realize, oh, that's going to be too long, then you can cut off what you need of one and then replicate it across the other 5. Alright, so while those are setting up, I want the glue to dry nice and good. I'm going to move on to step 6, which is assembling the uprights and the upper structure, as it says. To do that, you're going to need your 3 long extruded aluminum sections. I'm going to start with the base, and then I have my my top portion readily available too. You're going to need 9 T-nuts and 9 cap bolts or Allen head bolts. So here we're going to go. We're going to put 2 in each one of these corners, 1 in the top, and what they say is that the T-nuts need to be aligned vertically to be able to put the extruded aluminum pieces in. So I'm guessing it's a pretty snug fit. And then we're running into another fat finger issue with me. So I'm gonna grab some needle nose pliers to make my life a little easier. Alright, so I've aligned my T-nuts vertically. I think that went in. Double check. Oh, still got further to go on the bottom. Gotta make sure that they go all the way to the end down here. And one of my T-nuts has adjusted itself incorrectly, so I'll reorient it. Alright, let's try this one more time. Gotta keep going. It's supposed to go flush with the bottom. Yeah, it's certainly taking some pressure to get there. I'm going to try the other ones. I might have to come back and knock or tap that one in with a mallet. some small plastic shavings that are coming out of the bottom from doing this. So, although these were very nice prints of these corners, I'm sure that there's some slight discrepancies in size for the extruded aluminum. Okay, so there's those three, or excuse me, those six. Now we're going to move up to the top. Put the T-nuts in here. Same process. Now, for starters, I'm just going to try to make these go flush. But in reality, the extruded aluminum is supposed to slip past the top by 10 millimeters. Something to knock my T-nuts straight. There we are. Alright, those are all straight. I'm going to flip this back over. It is back over. I'm sorry you guys can't see it. It's out of the picture frame, but I am going to slip the aluminum extrusions 10 millimeters past. Kind of just working my way down. It's 10 millimeters. Where are we at? There we are, 10 millimeters. So then we're going to tighten down the T-nuts on top. Alright, this thing's pretty good size. And that completes step 6. They do say at this point to go around everything, not just what we just did, but everything, even these ones down here and up in here. Make sure all of your T-nuts are tight. So do that before we move on to step 7. Alright, we are moving on to step 7, where we're going to be installing the belt tension adjusters. And what's required of those is 3 M3 by 30 millimeter bolts. I think there's only 3 that come in the kit. 3 nylock nuts also, and then 3 washers. Now there are 2 different sizes of washers that came in my kit. For this step you're going to want the bigger of the 2 sizes. Alright, and what we're going to do is we're going to slip a washer on these, slip a washer on a bolt, and underneath there's a little hole kind of similar or close to where your bearings are, right in here. I'm going to put the nylock in there. And we need something to push it up a little bit so that it can engage with the threads of the bolt. There we are. And you can tell when, yes, you can certainly tell when the nylock has been engaged. Do that again. We want to make sure that the washer stays on top of the extruded aluminum, and then tighten it down. Ooh. I am getting a little spinning by the nut underneath, so I'm going to grab a little point here. Just a snug. All right, and that completes step 7. All right, we are back. Moving on to step 8, which is building the vertical slide assemblies, as the manual calls it. The manual stresses, and I am going to stress, these vertical slides can slide off the ends of the vertical bars. You don't want that to happen. Apparently it is difficult to get them back on and could damage them, or difficult to repair, as it says. I haven't even taken them out of the package yet. I want to show you what you're up against so that you don't get surprised by, oh, they slide right off as I open it up. So, you got your linear slides and rails. You got your 6 tie rods, and the other pieces of material you'll need for this step. You're going to need your 3 vertical slide mounts. These are the plastic printed pieces, and you may find that there's a bit of stickiness to the bottom of these. My guess is that these were printed and the plate that they were printed on was covered in hairspray. That is a common trick to get prints to stick well for printing purposes. If they are sticky, it's probably easy enough just to wash them off, maybe get a toothbrush in there, clean out any residue, because hairspray is water soluble. That's that. You will need 6 15mm Allen cap screws, cap head screws, 6 8mm cap head screws, 6 of your longer button head screws, 30mm pan head as they call them, 6 lock nuts, nylock nuts, 24 T-nuts, and this is for when we start prepping the slides to get mounted in the rails of the printer, and 24 8mm Allen head Allen head cap screws. So 24 of these, 24 of those. And so we're going to get going with this. Let's see. So first things first, I'm going to open up the package. Kind of show you what to expect. Pretty well packaged, bubble wrap, with packing tape. Oops. There we go. Very nice. They are oily, so keep that in mind. Nice. They don't seem to want to run. For example, if I tip them, they'll stay in place. And that may be until the bearings inside get all oriented correctly. I don't know. But there are a bunch of ball bearings inside here that run in these grooves. And you do not want to have this run past, because I'm guessing those ball bearings will fall out. Also of note, these cuts, although they look relatively precise, I can already feel that they are kind of sharp. So do keep that in mind. Don't cut yourself on those. Alright, let's start by orienting these this way. And the way it says to do this is we're going to take one of our vertical rail mounts, these guys, and we're going to grab two 15mm cap screws, which are going to go through these larger portions. That does not appear to go all the way through. Let me double check, make sure I got 15mm. Not 15. Just kidding. Sorry, guys. This just reifies the fact that you need to measure your screws before you assemble this thing. There's the 15mm. Sorry about that. So, going back, 15mm screws go on the thicker portions, and we'll use the 8mm ones on the thinner portions. And our slides are already threaded or tapped to accept these 3mm bolts, screws, whatever you want to call them. So it's just a matter of screwing them into the holes. And looking at the way that these are cut, lengthwise and whatnot, it does not appear that there is any difference in orientation, top or bottom. So however you choose to orient them is your call for the time being. And moving on to the 8mm. I am keeping all of my screws loose, at least a little bit, until all of the threads go in, and then I'll tighten everything down. There we go. Great. Now, next step will be to put on the carbon fiber rods. And to do that, I'm going to take one of these nylock nuts. Actually, before I do that, I'm going to switch to my 2mm or number 2 Allen head. I'm going to take one of the hex nuts, drop it in there. Then that pan head screw is going to go through one of the ends of our one of the ends of our tie rods. Get this all ready to go. I'm going to thread that on. Gotta make sure that the nut stays in the nut keeper area in there. But yeah, that's good. Nice, good range of motion. Excuse me. Now we'll do the other side. There's that portion. Switch back to here. Now, we have by assembling these in this orientation, we have now established a top and bottom. The fatter portion, or the portion that we attached our tie rod ends to, being the top. Now, we're going to put 8 cap head screws and 8 T-nuts on each one of these linear rails, and we're going to skip every other hole, but we're going to start with the first hole. Alright, skip one, so skipping that one, moving on to this one. Alright, that completes that step, but listening to what is in the manual, I'm going to grab some painter's tape. And I'm going to tape around here. So these can't slide anywhere. Again, they don't really want to slide anyway. They're not going anywhere necessarily, but just to be safe, because again, damage can occur. The attempt at repairing those is difficult, they say. And again, I do believe that is due to the fact that those ball bearings inside those slides would come out. So, until we move on to other steps, let's keep these secure. There we go. That completes step 8. Alright, we're on to step 9, which is attaching the linear slides to the vertical extruded aluminum pieces of our Kossel. What I have here is the top of the Kossel here, pointing towards you, towards the camera. And what we're going to do, temporarily I'm going to remove the tape that was preventing this from going anywhere. There we are. Keeping a good hand on it. And before I set this down, I'm going to try to orient all of my T-nuts, hopefully vertically, so they'll just set right in the grooves. That wasn't very bad at all. I'm then going to relatively snug them up a little bit. So hopefully I can slide them, but oops. There we go. Relatively snug. So I want to slide them. The goal is to have them, the bottom down here, sorry, no, it's at the end of the edge of the screen. The bottom of this needs to be exactly 120 millimeters from the top of the plastic corners. So, let's see here. So just as an example, from the plastic corner here, we're going to measure up 120 millimeters, and that's where the bottom of our rail will be. I am temporarily unscrewing and then rescrewing each of these screws, and the reason why is if I had screwed on the T-nut too far prior to placing it in this extruded aluminum, it is possible that it is too far tightened down to grab kind of the inner rail of the aluminum. So I'm just backing them off and then tightening them back down again to make sure that they do their 90-degree twist with the two wings facing out. Can't see that, excuse me. So I want to make sure they don't stay vertically. I want them to turn. That's supposed to happen when you're tightening them down. But to make sure that happens, I'm backing them off so there's plenty of room to play, and then tightening them down so they'll twist and lock into place. So this rail is in place where it belongs. It's 120 millimeters off of the bottom of the top of the corner, the lower corner. I'm going to take that tape that I had, and a good preventative measure is just making sure that this doesn't go anywhere. We're going to tape it back down. That's complete. Now, the next thing we're going to do is we're going to grab these U-shape or C-shaped items that are laser cut, and these are going to be the bottom stop of the bottom stops for this rail. So this is what's going to prevent these slides from sliding too far down. Tighten it tight, but remember, this is acrylic. Acrylic has a tendency to crack, so it's delicate. Be careful with it. Now, those are firmly attached, so now our slides cannot slide off the bottom. We will, when we attach the end stops on the tops, that's what's going to prevent this from sliding up on the top. We're not to that point yet, so we're going to keep the tape on. And that's going to complete step 9. Alright, the next step we're going to do is install the belts. Step 10. Now your kit comes with one roll of approximately 5 meters in length of this belt, GT2 belt. Now the manual says the minimum length for one belt is 1,500 millimeters, and they put in parentheses 1.5 meters. That equates to 59 inches for us English or standard measurements. To be on the safe side, I've decided to cut each one of my 3 belts to 60 inches, which should give me an extra 1 inch of play, slop, whatever you want, excess to work with. So what I'm going to do is I'm going to string up all of my linear slides with their tie rod end mounts, and that's where we're going to install these. To start with, I'm going to lower one. Let's see. I'll lower this one into view of the camera, taking my tape off. I know I have a stop down here. Let's see what I can do about making sure you can see this. There we are. So what we're going to do first is make a little loop. And we're going to get a zip tie. I'm going to loosely start this zip tie. Now, somewhat loosely start the zip tie. There we go. Now, the teeth are going to face in, and you'll notice that there are two kind of square pegs that stick out. We're going to wrap this around the upper of the two square pegs. And I gave myself some excess for a reason. I'm going to go a little bit more. There we are. And I'm going to zip tie that into place. So the teeth kind of interlock with one another on the belt. Great. Now we're going to string it up over the bearings at the top and back down. And we're going to go underneath the unit. And then back up, making sure that the belt goes into the toothed pulley that is on the stepper motor. Now, if you remember, I have not tightened my stepper motors, or my pulley on my stepper motor yet. That has not happened. I'll be doing that in the next step, but what I want to make sure happens is that this belt isn't being pulled on some diagonal in some way. So I want to make sure that the pulley on the bottom is parallel or directly in line with the belt above. I suppose if you happen to have a plumb bob, you could find that out, but I think this will work itself out no problem. So now I'm going to pull most of the slack or slop out of this. And now I'm going to wrap it around here. Oops. Trying to make it pretty tight. I know I have my belt tensioners above, but I'm trying to make it tight. Alright, I think we're going to call that tight. I'm going to grab another zip tie and zip tie around this set of belts on the lower portion. Again, making sure that the teeth of the belt interlock or face in with one another. Alrighty. Happy with that. I'll move on to the next one. Excellent. So now, I'm going to choose to leave my tails a little long at the moment. I'll cut them off once I'm real satisfied with this. But the slides are working as intended. So the next step would be to put the little spring clamp or belt tensioners on. The way that you do this is you'll hook it on with one leg. Using a pliers, you'll pull back the other leg, and then the spring mechanism will tension the belt a little extra. And you do want to try to get the belts tight by hand for starters. Let's see here if I can do this so you can see it. Go down here. You really can put this belt tensioner anywhere within about 4 inches top or bottom of where the linear slide kind of mounts up, because remember we have a stop down low here, or down low here. That's that U-shaped thing, and we're going to have up on the top. We're going to have the end stops, which are going to prevent it from going any further. And we have approximately 4 inches of clearance on top and bottom, so we do have some room to put these things. But the way we're going to do it, make sure I get this right, it's important that the barrel of this, and you can see, tilt it the right way, the center portion, we'll call that the barrel. It's important that the barrel be on the outside of our belt assembly. So again, looking at this kind of in this orientation here, on an outside, we don't want that barrel on the inside. So let me make sure I do this right. I'll put it down here. Yep. So I'm going to hook one leg. Again, this is very difficult for me to show you. I'm going to hook one leg, coming from the outside, hook one leg in. Then I'm going to go for my pliers, because these ends of these springs are a little sharp. And I'm going to bend the other end one more time. Hook one leg in, grab the pliers, oh, I haven't got distance. Again, it is important to have tension on the belt, so it doesn't surprise me that these aren't the easiest thing in the world to install. There we go. And that certainly takes up any of the slack on the belt. Again, it's very difficult for me to try to show you on camera, but if you look over here, extremely hard for me to show you on camera. Let's pop this up. Hopefully you can see kind of the track of the belt. Again, disregard the tail that I have on there. So you can kind of see how that is sprung. The barrel, if you will, is on the outside. Yeah, it's real nice. Nice and taut belt, and that's important. So I'm going to put that on the other two. There's our three belt tensioners installed on our belts, and that's going to complete step 10, installing the belts with the tensioners. So now is the time that I want to tighten up, or wanted to tighten up the pulleys on the stepper motors. And now is a really good time to do that too. We've already got our belts established as to where their resting places are, tightness and whatnot. And now is also a good time where we can cut off the majority of the tail of the GT2 belt as well. But what I did, as I'm cutting these, I grabbed hold of, make sure I can see this, I grabbed hold of the two pan nuts, if you will, that held on our tie rods, and I ran that up and down a fair amount, making sure to stay on the track, because remember, we don't have anything that's going to prevent it from going off on top. But I ran it up and down a whole bunch. Maybe 30 to 50 times up and down, relatively fast. And what that did was, since we didn't have the pulleys on the stepper motors tight yet, it allowed them to track back and forth until the pulley found a natural resting position where it would want to be in line with the bearings on the top side. So by going up and down a bunch, we're able to find the natural location, basically as perpendicular or vertical, parallel, actually, I think the right word, of the pulley to the bearing. And that's going to put the least amount of wear on the sides of the belt, keep it tracking nice and straight up and down, no strange pulling in any direction. So once you've gone up and down a bunch, and the pulley has kind of naturally found its resting position, you want to stop with one of the grub screws pointing up, and then you can just reach right in there with an Allen head wrench, or an Allen wrench, and tighten one of them down at that point. Then you can use it, the slide, to advance it so you can get to the other, because there are two on each of the stepper motors. And again, once everything is kind of nice and where it belongs, you can cut the GT2 belt excess. Make sure you leave a little bit left over in case you need to take this thing apart and restring it, or restring the belts so you have enough so you can grab onto it. I've left about an inch. The recommendation in the manual is 40 millimeters, which is like an inch and a quarter, so somewhere around there. And they also, I believe, say to put a second tie wrap. If indeed that is the case, if I have enough tie wraps, I will do that as well. But I've got one on each. Everything is good. I don't have to worry about these linear slides sliding off anywhere, because the resistance of the motors is preventing them from sliding. But I got to keep in mind that there are no stops on the top yet. We haven't put the end stops on yet, so I'm not going to just go up and down willy-nilly. I'm going to pay attention to the fact that these still could raise off of the track. Alright, so that's just a little tip on how to align your pulleys with your bearings now that we've got the belts on. Moving on to step 11, which is building the print head assembly. This is the heated item that will move around and deposit the filament in the pattern that we have predefined in the software. Yeah, so to begin, you're going to need 5 of the panhead bolts with 5 nylocks for that. You also need 2 15 millimeter cap head or Allen head bolts with nylocks. That's to attach the fan. These are for actually attaching the hot end clamp. This is the hot end clamp. It also holds the fan and your servo. And this is, I believe they call this the end effector. This is what actually connects to the other end of those tie rods. So, what I'm going to do is first, I'm going to place my button head, pan head screws on here. With a nylock. I know there's 6 holes in the top, but you'll notice there's only room, or there's only 5 holes in the clamp underneath, due to the fact that there's a void to be able to put the hot end in. I guess that is normal. But it does give you some freedom for what orientation you want to point the hot end. Not that it really matters. Something along the lines of that. Now, side note, I did have to drill out all these holes a little bit. This top portion, not so much. But the bottom portion I certainly did. And of all the prints in the kit, unfortunately, this is probably the poorest of them. I'm also not wild about the design, but that's neither here nor there. Again, this is going to hold the fan. It's going to clamp the hot end down as well as hold our servo. Now, getting onto the servo portion. Excuse me. The servo mounts with one screw with the splined end, the wide end, furthest away from where it mounts. So what you need to do is you need to push your servo into place. And with a pin, this is my recommendation, with a pin, go through the hole that's in the servo for mounting purposes and identify where you need to make a hole in the clamp, because there's no hole there. If you just try to drive a screw in without making a hole, you're going to wedge or pry apart the layers of filament that this clamp is printed from, and you're not going to get a very strong grab with the screw. Also, the screw for these things is pretty tiny. I gotta find it. There it is. It's pretty tiny. So, unless you have a drill bit slightly smaller than this so the threads can actually grab, I have a recommendation. Get a needle or a bobby pin, or safety pin, I guess that's what this is, not a bobby pin, excuse me, and heat it up. After you've already made your initial, mark or pinhole or whatever for where the center of your mounting hole in the servo is, if you heat this up, get it red hot glowing with a lighter, you can then melt a hole through the PLA plastic that makes up this mount, which actually is going to only fuse the layers better and give you a better hole which the screw will then screw into. And then before you actually assemble all this, go ahead and take this, screw it in relatively all the way, just so that you've kind of got some thread started, so that when it comes time to put it in with the servo, it's a little easier. Alright, so again, our servo is going to go in. Little screwdriver. Yeah, not crazy about that servo mount with one screw, but so be it. Oops, one of my stickers is coming off of my servo. Yeah, we'll pull that off. We don't need it. We all know that they're a Tower Pro servo. Next, I'm going to mount my fan, and the way it appears in the manual, since there's no blowing direction on this fan, is that the sticker is facing in towards the center, and I'm going to be mindful of where the cables are coming out because I'm going to try to keep them all together. Then I will drop 2 of the 15mm bolts through here. You may want to test fit your bolts in here. You might have to drill them out as well. Grab a nylock. Need 3 hands. Hello. Again, the other nylock. I have thrown the nylock out. Again, the airtight fit. Almost there. Alright, snug it down. So the fan is in. Now, to do the hot end, I'm going to remove this clamp temporarily. Now, the manual recommends that you orient your hot end so that the cables all kind of come out the same area, which we will do. Certainly a tight fit. I recommend you test fit these pieces before they're all bolted together. It's less cumbersome that way. That's tight. There we go. A little bit of persuasion, nothing too crazy. You would want a tight a tight fit around these anyway, so that does make sense. Then we're going to go tighten down all those 5 pan head screws on top. And the pattern for tightening these down, it's always a good measure to get them snug and then alternate your or stagger your screws so you don't end up tightening down on a diagonal. So tightening one down, skipping one, going to the next one, skipping one, going to the next one. And since there are 5, it'll be kind of a star pattern. Lastly, this one back here. So again, we've got our hot end, cords coming out the back, our servo, which will be doing our auto leveling, which is a great new feature in the Marlin firmware. And then we also have our fan right there to cool our hot end so that our filament doesn't melt prematurely and end up clogging up this thing. So that is how that is built. The connector here, this brass connector, that there'll be some tubing that fits into this blue end portion. It would appear, looking at this hole here, that I have to drill this out a bit. I will follow up with that because clearly it's not going to thread in as is. This may have to come apart. I will get back to you. So please, before you do this, check the next video. or excuse me, the next section of the video. Alright, so to continue on with the build, I'm going to talk a little bit about the assembly of the auto tuning arm with the servo and the micro switch. What you're going to need is you're going to need this piece of laser cut acrylic. You're going to need a micro switch, servo with the accessories that would come with it, and the 2 meters of 22 gauge wire that in my case came in a package labeled 22 gauge extra wire. Start off with, while my soldering iron is heating up here, what you have to do is you need to drill out this piece of plastic on the end with only one hole. So the top here. You have to drill all the way through, and there is a small pilot drill or pilot hole already there. If you have to drill all the way through with a 5/64 inch drill bit, or something really close. If you're looking for something to gauge how big it needs to be, go ahead and look at the screws that come in the servo accessory packet, because the purpose of that hole, that 5/64 inch hole, is to be able to put a screw through it, which will then screw into the top of the servo here in this little hole. Once you've got that 5/64 inch hole drilled all the way through, you need to drill about halfway through this acrylic with a 3/16 hole. And what that does, and that's a pretty perfect fit, and you want that. What that 3/16 hole does is it will allow the leveling arm to slip over this white splined end of the servo, and the friction between this and that white piece plus the screw going through the center should keep the servo arm in place. So that's that, and we'll get to that in a moment. For starters though, we're going to take our micro switch. We have some soldering to do real quick, and I have a little 15-watt soldering iron. Take my gray wire first, and for fun I'm going to put it in on the side that the little micro switch kind of pivots from. Put it through the holes in the terminal there. And I'll solder this up. Now the red is going to go all the way on the opposite side, so you're going to ignore the terminal in the center. And that reason for that is because the way that we want this to trigger is we want, when the plunger or the button is depressed, we want it to break a circuit as opposed to complete a circuit. Just inspecting my solder job. Pretty happy with that. Let's see if you can see that a little better. So again, gray wire to the corner that the arm depresses, and then red on the opposite side. Alright, now we'll grab our servo, and I'll turn off my soldering iron. Ideally, you would use the smaller of the two screws, because that was what is intended for the center of the servo. Which you may find, after we do this, we need the larger of the two, since we will only need one screw to attach the servo to the mount on the hot end. So you're going to take the side that you've drilled your 3/16 inch hole. You're going to push that on to the splines on that white portion of the servo. And push it down all the way. Be gentle with it, but you need to push it down all the way. Alright. Now check and hope that your oops, I need a screwdriver. That your screw can actually come into contact with that white portion underneath. And then screw it in. And that's going to keep that in place. As for how you're going to attach the micro switch, I'm going to take take 2 of my cap screws and I'm going to use the fact that the hole in the micro switch is only slightly smaller than the size of the screw. Basically ignore a nut altogether and just use the threads in the plastic to hold this on. Just want to snug it up because since I don't have any real nuts on this side, I don't want to strip the plastic. And finally, you could then run some Kapton tape around the wires and the arm. You could also use a zip tie. And that's how you create your auto tune arm or auto level, auto Z arm for the Kossel kit. Alright, like I thought, if your end effector, again, I think that's what this is called, this hexagonal or hexagon shaped portion on top here that will mount to our tie rod ends. If it doesn't already have a hole big enough for the what they call the screw-in push-fit connector here, this push-fit connector, this little brass item with the blue plug on top that was threaded into the hot end when you received it. If it doesn't have a hole big enough for that to pass through, you're going to have to drill a hole for it. It took me a 3/8 inch drill bit, drilling all the way through the center of that to make a hole big enough for this to pass through, and then that brass piece does screw into the top of your hot end. If you want to tighten it down snug, use a 10mm wrench. That seems to be the right fit for it. So I would say for this assembly, this whole apparatus here, drill out all of your holes to a 3mm hole so that your bolts will pass through. Use a hot safety pin to make a hole for your servo, and then depending on the size of hole in the center, you're gonna have to drill out a hole for your push fit connector as well. And then just make sure everything is good and snug. Cables are routed where you want them, and that completes step 11. Alright, so the next step is to attach the hot end, or the print head assembly as they call it, to our tie rod ends. Now, we've already had to do some pre-drilling on some of this apparatus here to get the different bolts and things to go through nicely. Well, I found out also that for our pan head screws, which you need 6 of and 6 nylocks to go into this, you also need to drill out the holes a little bit too. So that was with a 3mm drill bit. If you look real close, you'll see that there's a hexagonal hole on the insides. That's to kind of capture the nylock, and it's important that those recess in there. So we're going to make sure that that happens. So we're going to push one of these pan head screws, the 25mm pan head screw, through there. Yeah. I'm going to grab a nylock and hopefully be able to get it started on here. Alright, it's at least started. I might need the pliers to hold this. Gotta make sure it's going in the grooves. There we go. Alright, and that's captured. I think next step will be to move across the way here. Alright, I want to check. Yeah, motion seems pretty good. Very good. So again, I just want to look real quick and make sure that all of those bolts are in the recesses within the, again, that hexagonal piece, the end effector, I believe they call it. Just make sure that they're in there and captured well, that way they can't back themselves off. Make sure everything nice and tight, and then again, do check your motion. Do be careful though. Remember, we don't have anything on the tops of the linear slides yet, so we don't want to run them up so high that they come off. Alright, that completes number 12, or step 12.